I am sharing the whiteboard. And okay, so we are going to study about the Excess3 codes. Okay, so these codes are basically written for the decimal numbers 0 to 9 only. If any other code we want to make, for, let us assume for 10, 11, 12 or any other multi-digit number, we want to make Excess3 code, then there we need to write the corresponding Excess3 of each bit. Means you already know about the BCD codes. So this is I am writing decimal numbers. So we are taking decimal numbers only 0 to 0 to should be
9.
attentive beta. Yes, 9. So here these are the decimal numbers. I am writing directly BCD. BCD means what? Binary coded decimal. Means we represent only numbers from 0 to 9 here. Valid codes are from 4 times 0 in binary to 1001 only. 9 means 1001. Any other combination of 1 and 0 like 1010, 1011, those combinations are invalid here. These are the 10 combinations which are valid here. So if we want to make any other multi-digit number, what we do, for example, if we want to write BCD of 25, we will write the 5 code in BCD here in 4 bits and 2 code in BCD in 4 bits. So that is the way to write any multi-bit number in BCD. Similarly, in Excess3 code, we are having codes 0 to 9 only, and remaining number, if I want to write any multi-bit number like 10, then I need to write in 4-bit the Excess3 of 0 and the Excess3 of 1. Now, as already we know how to write the binary numbers from 0 to 9, but the condition is here we have to use 4-bit binary numbers. So 0 is going to be represented by 4 bits of 0. 1 is going to be represented by like this. 2 means 0010, 3 means 0011, 4 means 0100, 5 means similarly just we are writing the binary combinations here. But we have to make sure the binary combinations up to 9 are valid. Above 4-bit combination from 10 to 15 are invalid in case of BCD. So now if we want to write the 25 BCD, so we have to write the BCD of code of 5, that is 0101, and BCD code of 2, that is 0010. In this way we can write any BCD number. So these are the BCD codes where 0000 to 1001 are valid bit combination and invalid bit combinations are 1010 to 1111 are invalid BCD combinations. Is it clear? Yes.
Yes,
So
ma'am.
I hope this is clear. Okay. So in Excess3 code, what we do, if we want to write the Excess3 of let us say 5, so we have to add 3 here. We have to add, so there are two ways to add 3. Either we can add in decimal number 3, we know the answer is 8 and we know how to write 8 in binary 1000. One way is this way to write the Excess3. So the Excess3 of 5 will become, Excess3 means what? Addition of 3. Excess means extra. 3 is going to be added. Then the 5 code will be this 1000 combination. Other way to find out the Excess3 code is to write this 5 in the binary number, and every time we have to add the binary 3. So binary 3 is going to be written as 0011. We should know the addition rules of the binary. We already know that 0 plus 0 in binary is 0. 0 plus 1 in binary is 1. 1 plus 0 in binary is 1. 1 plus 1 in binary is 1, 0. Because we write 2, 1 plus 1 is 2 in decimal if we write in decimal. But in binary we write 2 as 1 0 bit combination by making the use of 1 and 0 bits only. So here what happens, this 0 will become the sum bit and this 1 will become the carry bit. This is similar to like if we want to add 15 plus 8. So if we are going to add 15 plus 8, the answer will be 13. 3 will be here and 1 we are going to add here. 1 plus 1, 2. In this way, the same type of concept remains here. If this kind of 1 plus 1 will occur, then we have to write 1 0. 1 plus 1 is here now, so we have to write 0 here and 1 will be the carry bit. 1 plus 0 is 1. Now 1 plus 1 is again 1 0. So 0 we will write and we will write carry here. So this is the carry line. So 1 plus 1 is 0 and we have to take carry here and 1. Now you can write the Excess3 code in two ways. Either you add decimal 3 and convert it into binary, or you do the binary addition. Both are correct. You can see the both are the same code. In sometimes if in addition, if they all three bits become 1, then that time you need to take care of 1 plus 1 plus 1 is 3 in decimal. So we write 3 like 1 1 in binary. So if we are calling about the binary, so we should write 1 1. Here 1 will be the sum bit and 1 will be the carry bit. If this particular condition occurs, if we take the carry, all three bit ones are here. So we have to simply write here 1 and take carry 1. So is this clear? So how we can write the Excess3 of BCD? We have to add either 3 here plus 3. So how we write 3 here? How we are going to write here? 3 0 0 1 1. Means 0 is representing by this bit combination of 3. 1 is representing by adding 3 means 4. We write 4 like this. 2 we can write 5. So now it is in sequence because these are successive numbers only. So this will also come in sequence. So here we have to write 5. 3 plus 3 is 6. So how do we write 6 in binary? 0 1 1 0. 4 plus 3 is 7. 0 triple 1. 5 plus 3 is 8. 1 triple 0. Right now we have done this in both ways. Similarly, so on. 9, 10, 11, and because 9 plus 3 is 12, so 12. So here in Excess3 codes, the valid range is from this to this. So if someone is going to ask you what are the invalid combination in Excess3, these were the invalid of BCD. In Excess3, the invalid numbers are 0 0 0, 0 0 0 1, 0 0 1 0, and last 3 means from 13 1 1 0 1 to 4 times 1. These all are Excess3 invalid codes. These are valid one. So now if we have to write Excess3 code of, let us assume 15 or any other number, 215 let us assume. So we have to write the 2 code here. 2 in Excess3 is this. So we will write 2 in this way. 1 in Excess3 is, in Excess3 1 is 0 1 0 0 0 1 0 0. 5 in Excess3 is 1 triple 0. Is it clear? So this is Excess3. Is it clear? Okay, fine.
Yes, ma'am.
Okay, so please quickly note it down or take the screenshot of the window so that I can teach another topic. Now, there is one important property of Excess3 code which is known as that these codes are reflected codes. Reflected codes, or we call these codes as self complementary codes. Self-complementary codes means what? If we take the nines complement. Now, first we should know the nines complement. What is the nines complement? If we take two nines complement of any number, we take this in decimal numbers. So we have to subtract that digit by 9. Means if we want to take the nines complement of 4, So we have to do 9 minus 4. So 9's complement of 4 is 5. Similarly, if you do 9's complement of 9 will be 9 minus 9. 9's complement of 9 will be 9 minus 9 means 0. 9's complement of 8 will be 9 minus 8 means 1. 9's complement of 7 will be 9 minus 7 means 2. In the similar way, for 6, 3, for 5, 4. In the similar way, for 0, it will be 9. So, the reflected codes or self-complementary codes are those if we take the complement of 9 in that code, then it will give the code of 0. Means here Excess3 code 9 is this code. This 110 is representing 9 in Excess3 code. Code means what? Code is means we are writing the same information in different binary combinations here as per the code or as per the language we use. So here 1100 is 9 only. So if we take the complement of 110, it will be 0011. One's complement 0011. So you can check that 0011 is the code for 0. Similarly, you can take the ones complement of 8, that will become 0100. So here you can see the code of 1. One's complement, this 9's complement should be the 1. So if we are taking the complement of binary here, then we are getting the code of 1 here. So these codes are having the property of reflection. Reflection means these can be represented like this way. If we do the complement, then we get the 0, 1, 2, 3 directly codes. So reflected codes. So this is the reflection of 0, means complement of 0. This is the reflection or complement of 1. This is the complement of 2. In the similar way, so on. So these are the having the property of reflected codes or self-complementary codes. But if you check the same thing for BCD, so these codes are not reflected codes. BCD codes are not reflected codes. So I hope the reflected codes or self-complementary codes are clear to you. Okay. So I am going to change the board here. You can take the screenshot. I am going to clear the canvas. So any doubt up to here? If you are having any doubt, you can ask me. If you are not having any doubt, then I will explain the other topics. Okay, so I am going to explain the other types of codes which are known as 2421 codes. 2421 codes. So these codes are basically weighted codes. Excess3 codes are not weighted codes. One thing you need to remember that Excess3 codes are non-weighted codes. What is the meaning of non-weighted codes? Here 0 can be represented by 0011. So there is no meaning of the positional weights. We generally define these bits by some positional weights. For example, in 2421, this bit will having the weight of 1. This bit will be having the weight of 2 again. In BCD codes, we use power of 2. 2 raised to the power 0 means 1. 2 raised to the power 0 means 1. 2 raised to the power 1 means 2. 2 raised to the power 2 means 4. 2 raised to the power 3 means 8. So BCD codes are also known as 8421 codes, and these are the weighted codes. Because if we write 3 here, 3 in BCD code, then we have to write the sum of these two positional weights. 2 plus 1 is 3. So this is weighted code. While in case of Excess3, we write 3 plus 3, 6. So here it is not having any relation between any positional weights. So these are non-weighted and these are weighted. So similarly, 2421 codes are also weighted codes, because here the positional weight value is different. In place of 8, we are having 2 here, but these are basically weighted codes because every bit position is having some weight, having predefined some weight. Okay, so if we want to write the equivalent or in 2421, again I am writing this table up to 9 only. Any multi-digit number will be formed by using each bit respective codes only. So you already know how to write BCD or binary of these numbers. The same table which we have just written, 1, 2. This is optional. If you want to write, you can write. If you don't want to write, you can skip it. If someone is asking about the 2421, you can skip it. 1000 and 1001. So now, how to write 2421 code? Now 0 is very simple to write. 2, 4, 2, 1 are the base positions and we have to write 0. So we have to write 0 in similar way. Now next number we need to write 1. So we should put high in place of 1 only. We are going to make the number by addition of these positional weight. Now there are two ways to write 2. One way is to write 2 by making this high. This 2 high, remaining bits are 0. The other way to write 2 is to make this 2 high and remaining 0. So generally we don't use this combination. We use this combination valid because after completing these set of codes, I am going to explain that these codes are also having the property of reflection. If you are going to use uh, this scenario, here we are taking the LSB position first. So by making consideration that we are giving the preference to LSB position. LSB means least significant bit, this, and MSB means this is the leftmost bit, the first bit of the number, most significant bit. So similarly, we can write 3 in 2 ways. 3 in 001 way, simple way that we used to use generally. Or we can write the 3 in other way like this 2 high and this 1 high, 1001. Again, we are not going to use these set of combinations because if we use these sets of combination, it will not give the property of reflection. Now 4 number again we can make 2 and 2 high, but here we are going to make directly 4-bit high and this. 5 number. 5 number again we have two conditions. Either we use 2 to 1 high, 2 plus 2 plus 1 will be 5, or we can make 4 plus 1 5, but here we are going to use this first combination. Now 6. 6 again we are using this combination because at the end I am going to prove the property of reflection in which we are going to get the complement as the code. So that's why we are going to use these sets. So 9 is having the same combination and 8 is having no other combination. Simple to write. Now, what was the property of reflection? So these are 2421 codes are reflected codes, or we call it as self complementary codes, because if we take the complement of 9, we are going to get the code of 0. If we are going to take complement of 8, we are going to get 1. If we are going to get the complement of 7, we are going to get the code of 2, and so on. So let us check this. Is this happening or not? So first take the complement of 9. If you write the complement of 9, then it will be 4 times 0. Once complement simple. So you can see that this is matching to this. So means this code is reflection of this. Similarly, if you take 1's complement of 8, it will be triple zero. How we take 1's complement? We replace 0 by 1 and 1 by 0. This I have already taught in my previous classes. So now you can see this is the reflection of 1. Similarly, if we take complement of 7, so that will be 0, 0. So for 7 we can write in two ways, 0 triple 1 or in this way. If we write 0 triple 1 now, then 1 triple 0 will be the complement, that will not be the reflection of number 2. That's why we have written this number 1101. So always in examination, please make sure you are using these sets of codes. So 0010 means it is the reflection of 2. You can verify yourself. 6 complement will be 0011. Again, it is the reflection of 3. You can see here. Similarly, if you are going to take and so on, this is the reflection of 4. So that's why we call these codes as the reflected codes, where XS3 and 2421 are the reflected codes, but VCD doesn't have this kind of property. You can see if you take the complement here, 0110 will be there, which is not same as the 0 in the code. So that's why BCD are not reflected codes, while 2421 and XS3 codes are the reflected codes.